Hey guys. I'm going to be presenting today about why smart contract wallets are the future with EIP-4337. So as a little teaser, as mentioned before, I'm working at Nethermind. I'm a core developer. And you all probably realize what this is, right? This is a Bored Ape. Oh, almost. Not a CryptoPunk, a Bored Ape. But something I've been seeing recently with these Bored Apes is the following. Right. So as you guys can see, it quite often happens that these Bored Apes get stolen. It's important to realize, though, that they don't get stolen because of some problem in the Ethereum protocol. Rather, they get stolen because of phishing attacks. So the problem is with the UX of Ethereum. I don't think it should be this easy to lose $400,000, right? Just entering your seed phrase and seeing it go away in a flash. So this is kind of the motivation of this talk, right? I'm going to be talking about why EOAs suck, why smart contract wallets are better, the current problems with smart contract wallets, and how our EIP, EIP-4337, tries to solve this. So, first of all, what are smart contract wallets? This is a seed phrase, and this is what controls your smart contract wallet. Well, to be specific, the private key derived from the seed phrase does. And while this is cryptographically incredibly secure, there are still major problems. Instead of talking about it for a few minutes, I'm just going to let you read this amazing SKCD. So as you can see, the problem is with the humans. It's not with the cryptography. We shouldn't expect the next financial system to rely on people storing their life savings on 12 words on a piece of paper. Another problem with EOA accounts is their signature scheme. While ECDSA doesn't have any major problems by itself, it's quite restrictive, right? In Ethereum, you can only use the signature scheme for EOA signatures, nothing else, even though there have already been developed quite a few better alternatives. So, EOAs suck, we've established that, but why are smart contract wallets better? Well, first of all, their signature schemes are a lot more flexible. So an example of a smart contract wallet scheme is a multisig, right? Imagine that you have, say, 3 keys that allow you to control your wallet, but you need 2 of them to actually interact with it. So say if you hold one of the keys and someone finds it, you fall for a phishing attack, they just have that one key and they can't do anything with it by itself. Another example is social recovery wallets. What this means is that you have one central controlling key that can do basic functions in your smart contract wallet, but it's time limited and it can be replaced by a set of guardians, right? So if, say, you lose your controlling key for the smart contract wallet, you can go to your guardians and request them to replace it for you. Okay, so while smart contract wallets are amazing, they have some issues. The biggest of all, probably for the average Ethereum user, is the gas cost. You pay a very high gas overhead for using smart contract wallets, and we really shouldn't expect the average Ethereum user to be willing to pay 50, 60, 70 extra dollars for a simple trade, a simple transfer. Another problem, which is kind of the main focus of this presentation, is the following. All smart contract wallets on Ethereum right now have to be relayed with an EOA. All Ethereum transactions must be initiated with these EOA accounts. And this is a problem. This means that if you want to interact with your smart contract wallet, you either have to maintain a separate EOA filled with some ETH to be able to transact, or you can rely on some separate relayer service. So for example, Argent, one of the wallet providers, they maintain their separate relayer mechanism where if you want to make a transaction using your Argent wallet, they will use one of their own relayers and call your wallet for you. Now, there's a problem with this, which is that each dApp right now needs to develop their own relayer mechanism if they want to use it. And it's quite centralized because if it goes down for whatever reason, it's going to be incredibly difficult to transact with your wallets. This is what account abstraction tries to solve. Account abstraction has to do with trying to get rid of the requirement for EOAs to initiate transactions. So how does EIP-4337 help us get there? This EIP is called Account Abstraction via Entry Point Contract Specification. Well, this means nothing, so let's explain what actually happens with this. Before we get into that, this is a collaboration between us here at Nethermind, OpenGSN, with help from Vitalik as well. So the way this proposal works is that it introduces the concept of user operations. These are sort of pseudo-transactions that allow you to encode whatever you want to do with your wallet, similarly to transactions. These user operations get created by the user willing to use their wallet, and these users are going to send it to a special user operation pool that lives above the normal transaction pool. This is going to be validated and then broadcast over P2P like normal transactions. Then it's going to be picked up by entities called bundlers. These bundlers can be anyone. They can be miners, they can be MEV searchers, they can be you as well. These bundlers are going to take these user operations, they're going to bundle them into one transaction, vanilla Ethereum transaction, and include them in an Ethereum block like any other transaction. So an important thing to note is that the way bundling happens is that these bundlers route these user operations through a special entry point smart contract. Now, how does this actually work? So the bundler has their user operations. They call a special handle ops function in this contract. What it does is it goes through every single user operation that's being bundled, and it calls a special validate user op function in the wallet contract. What this does is that it allows the wallet to verify the signature of the user operation. It is probably going to implement some nonce mechanism, and very importantly, it's going to compensate the bundler for having bundled these operations. After it's gone through the validation for every single user operation, it's going to execute them one by one. But with this EIP, we also introduced a special new capability as well, paymasters. So instead of having to rely on your wallet paying ETH every single time, you can have your user operations sponsored by a paymaster. With this flow, what would happen is that first, the signature would be verified by the wallet contract, but it would not pay. Instead, a stake would be deducted from the paymaster, and it would be relied on to pay for the user operation. Afterwards, the user operation gets executed like any other, and then a special accounting function called post-op is called on the paymaster. So if you want to actually implement this interface, what do you do? Well, in your wallet, you have the validate user op function. This takes in a user operation, the request ID, which is kind of like a hash of the operation, and the required prefund. What you're probably going to want to do is validate the signature in whatever way you want. Important to note is that you can do any signature validation, right? An example here is ECDSA, like with normal EOAs, but you can use any verification that you want. Next, you're going to increment the nonce and then transfer the required ETH to the bundler. Okay, when this validation happened, then we're going to go back to the entry point, and it's going to, after a while, call the wallet again. Specifically, it's going to call the exec from entry point function, and here you can encode whatever you want. You can encode multiple batched operations. Basically, this is up to the wallet what it wants to do. If you want to include a paymaster, then it's slightly different as well. The paymaster is going to have to write a validate paymaster user op function. This simply decides whether the paymaster actually wants to sponsor the operation or not. If you don't want to, you just revert. If you do, you let it happen, and you don't do anything special. And finally, the post-op would take care of any extra accounting. So in the case of the token paymaster, as you can see here, we're allowing the wallet to pay with special tokens. So in this case, for a validate paymaster user op would check whether the user has enough of the tokens, and the post-op would deduct and swap the tokens for ETH and pay the bundler with that. So why is this good? Why does this solve the problems that we've outlined before? Well, most importantly, I think, We get account abstraction now. As Ansgar mentioned in his previous talk, there are lots of EIPs that are going to be included in the future forks, and there's very little space to play around with these sorts of utility EIPs. This means that since this EIP doesn't require a consensus change, no hard fork required, we can include it right now without having to rely on core developers to implement the proposal. We're going to incentivize smart contract wallet adoption. As mentioned before, EOAs suck, right? So the more UX benefits we can bring to smart contract wallets, the better. And we believe that this proposal is going to allow for lots of amazing composability. Following on that point, this provides a universal and widespread interface. What this means is that special dApps can now make their own paymasters, and they can interact seamlessly with wallets that implement the interface as well. This means lots of sponsoring and lots of cool new use cases for Ethereum users. Custom signature schemes. As mentioned before, whatever you can code in Solidity to verify the signature, it can work, right? So instead of relying on ECDSA, we can already rely on more amazing signature schemes like BLS, or even post-quantum safe ones like, for example, Lamport or Winternits. Paymasters. So paymasters are remember, are the things that sponsor user operations. They allow for lots of cool use cases. As shown before, you can pay with tokens instead of ETH if you use paymasters. You can also withdraw privately from ZK mixers. So Tornado Cash right now relies on their own relayer system to allow you to withdraw anonymously, but they are looking to move away from that as well, and this is a great mechanism for that. You can do very wacky use cases as well, like paying off-chain with a credit card. So imagine that you have a paymaster which holds a special private key behind some cloud server. And if you go through their Stripe API and pay for the user operation, they'd be willing to sponsor your operation for you, right? So you wouldn't even need to hold any tokens, or let alone ETH, to transact on Ethereum. This would be very useful for interfacing more with the current financial system as well. Since we're working with smart contract wallets, we can do multi-operations. So right now, if you want to do a Uniswap swap, you need to first approve in one transaction and then do the transfer and swap in the other transaction, right? This is quite UX unfriendly, as we know. So if we use smart contract wallets, this all goes away. Decentralized. So since user operations are propagated using a P2P layer, there's no one central entity that's required and that's trusted for this to work, right? It's quite in line with the ideals of Ethereum, and we quite like that because of that. Incentive aligned. So bundlers, important to note, they get compensated for bundling user operations on chain. What this means is that we don't actually need miner support initially to make this proposal work. Instead, we can just rely on MEV searchers to take care of most of the work, right? So as we all know, if you've been to the Flashbot searcher Discord channel, they will devour any sort of profit opportunity the moment it gets there. So they're quite reliable when it comes to working in their own self-interest. So they're going to be good tools for this. Following on from the previous point, it's very possible to do a slow rollout. On Ethereum mainnet, miners are very hesitant to adopt new changes to their client architecture. So we wouldn't expect them to adopt this mempool logic and all this P2P logic initially. Instead, as mentioned before, we can get started with this proposal on mainnet with MEV searchers, and then as miners see that, oh wow, this is actually pretty cool, and we should use this because we can make money, it's still going to work. Future-proof. Ethereum, there's a vision in Ethereum to move away from EOA wallets eventually. As mentioned before, they're very restrictive. You need to pay with ETH, you need to use ECDSA, and smart contract wallets have kind of been in the vision of Ethereum from the start. This EIP provides a very good stepping stone for that. So imagine eventually if we replace all currently used EOA accounts with a default upgradable smart contract. Well, that eventual smart contract could follow the interface of this EIP and be incredibly composable from day one from its launch. So there's been a lot of talk about this EIP, but let's actually give an example of how you might use it. Say you have 1,000 DAI in your Tornado Cash, and this is what you want to pay with your transaction for. You have your wallet, which has 10,000 USDC, and you want to swap it for a Uni on Uniswap. Okay, so you craft a user operation, and you send it to one of the compatible nodes. Right, it gets propagated using P2P, and the bundler picks it up, sees that it's profitable, and wants to include it on chain. Great. So they're going to call the entry point smart contract, and this is going to validate, first of all, that the signature is correct, and that the Tornado Cash is willing to pay for the transaction. Great. So now it's going to execute the wallet. Whoa. RIP. It's going to execute the wallet. Now your wallet is going to do its swap as it would. It might first approve the transaction, and then it's going to swap using Uniswap as you would normally. Then we see that this has worked. We did what we wanted to do. We swapped USDC for Uni. Now, remember, we have to pay the bundler for having included this user operation on chain. Okay, so the entry point calls Tornado Cash and the paymaster. And it's going to do another Uniswap swap to swap DAI for ETH, which is what the bundler needs. So we're going to get back ETH, and we're going to transfer it back to the entry point, which is going to compensate the bundler for their actions. If you think about this, this is like 10 or more separate operations. If you wanted to do this with EOAs, it would take you a lot of gas and a really bad UX experience. So this is kind of trying to show how much of an improvement smart contract wallets can give to the average Ethereum user. But what is the state of the EIP right now? Well, the EIP has two main parts, right? It has the entry point contract first. So the entry point contract already built. OpenGSN has done an amazing job with that. And it's currently undergoing an audit by OpenZeppelin, which should finish this week or next already. We're launching on mainnet straight after. We also want some software to support the bundling of user operations and the mempool behavior that we mentioned previously. So here at Nethermind, we've been working on supporting this EIP for our Nethermind client and for Geth as well. We have already built that, and our girly validator is already bundling user operations as we speak. So you can already test out this proposal right now. Okay, so we've talked about why EOAs suck, why smart contract wallets are better, the problems with smart contract wallets, and how EIP-4337 solves these problems. So what can you do? Well, if you're a smart contract wallet dev, consider trying to adopt this proposal and making your wallet compatible already with these interfaces. If you're a dApp dev and you want to sponsor users' transactions, consider making a paymaster, which suits your use case. For example, you could make it so that the first 10 transactions that a user does with your dApp get sponsored by you. Or you could make it so that they get sponsored if they hold enough of your special token, or if they stake some NFT with you. There's lots of use cases, and it's very custom because it's all written in Solidity. If you're a tooling dev, consider trying to implement some of the verification and mempool logic that we've developed in your libraries. And finally, if you're an Ethereum user, consider trying to pressure our friends over here at MetaMask and other wallet providers to start adopting smart contract wallet designs. And also, consider switching to smart contract wallets yourself. You might think that there's this extra cost that you're going to have to pay, but in the long run, if you hold any significant amount of funds in your wallet, it's going to be worth it. You don't want to end up like the people that I portrayed at the start with their bored apes that have been lost. So we're hiring at Nethermind. If you're interested in this sort of stuff, we'd love to have you interview. And yeah, I'm going to open up to any questions. Thanks.
All right, so if you guys can stand up and raise your hand if you have questions.
Regarding the entry point contract, who deploys that? Or like, yeah, regarding the entry point contract, like who deploys that? Or will there be only one entry point contract or multiple?
Great question. So the entry point contract is going to be a singleton. We expect that there's only going to be one deployed on any specific chain at a time, because this results in better network effects for users, right? Since all smart contract wallets are going to be specific to a specific entry point, we want kind of composability with that, right?
Hello. Thank you for the presentation. I have a question about the security issue. So if I was a dev developer and then would like to use the entry point to sponsor my users, then so in that case, how if then some malicious people and just create some dummy or utilize applications and to, for example, drain some tokens or drain some sponsor tokens from this?
So you mentioned the security issue, but I didn't quite catch what specifically you were referring to.
Yes, like the Sybil resistance.
Sybil resistance, okay. Yeah. So that isn't that big of an issue, right? Because like if you want to, I'm not sure quite what you mean with that, right? Because what happens with this is that you would make your user operations specific to one wallet and one paymaster if you choose to use one. There's no real Sybil resistance. We have several security mechanisms that we put in place to stop DOS attacks, especially during the validation phase of the entry point call. But when it comes to Sybil resistance, I can't think of anything that might be of concern.
Hello. So what do you think are the incentives for big wallets like Argent or Genosis to adopt this proposal instead of running their own relayers? Because in this proposal, you need to pay an extra transaction fee to the people that are including the transactions in the entry point. So what is the benefit of Argent, for example, to include this EIP?
Okay, so one is more resilience, right? If they're maintaining their own relayer system, that's very risky for them. Second of all, maybe more importantly, it's the composability, right? Composability with other wallets, and especially with paymasters. If Argent ever wants their user operations to be sponsored, or then they're going to have to adopt the interface, and this is quite a good UX bonus for the users.
I have a question on the scalability, or at least the increase in efficiency in these bundled transactions. Does it take less gas to make these more complex operations than doing them independently?
Okay, so you asked about the scalability of bundling multiple user operations. Yeah, good question. So right now the overhead per op is 26,000 gas. But there's also 28,000 shared gas in the whole bundling operation, right? So this shared gas would be divided by as many user operations as are bundled by the bundler. So there's a very good incentive for users and for bundlers to try and bundle as many as they can into one batch.
Who else had a question? Oh, you.
For a regular Ethereum user, what are some sample smart contract wallets that one can try today?
Oh,
it's louder and clearer.
Okay. What are some of the smart contract wallets a regular Ethereum user can try today?
What are some smart contract wallets that we're trying to...
No, smart contract wallets that we can try today. In case I want to try some of these, what should I look for?
I'm not sure I understand. But
what smart contract wallets exist right now that you could play around with to work with this?
Yeah.
So none yet, right? Because we haven't completed our audit. But people like Argent and Gnosis Safe, they're already hacking on proof of concepts with this ERC. So you're probably going to see some soon.
Okay, that's all the time we have for questions right now. In a few minutes, we're going to have another speaker up, so we're going to change over. And yeah, just wait a few minutes. Thank you very much. Give him a hand, please.